All right, so I'm going to use this video to just go over all of the questions I gave you guys for review. Since I wasn't going over any in class, I want you guys to focus on working and learning how to work as a team and using each other as resources as well. I wanted to use this time to go over any of your questions. Now, I'm going to go through these kind of quickly though, so if you have any more questions about it, just send me a message. All right, so the first one that we were doing, you were given k to the fifth times k cubed. So the first thing we look for when we have when we're solving this is, do we have the same base? And once we have the same base and we see that we're multiplying, our rule then is to add our powers. So it becomes k to the 5 plus 3, and that becomes k to the 8th. All right, that's the final answer for that one. Let's do the next one now. So let's just scroll down. All right, so now the next one that we're doing was p to the 6 over top of p. So remember, first thing, same thing, we look to see are our bases the same. Since they are, we know that we're doing division here, and division we subtract our power, so it becomes p to the 6 minus 1, because although nothing's written here, it's understood to be 1, and this is then equal to p to the 5th power. All right, the next problem was m to the 6th power raised to the 8th power. So now here we have power to a power. So remember, this is saying that we have m to the 6 multiplied by itself 8 times. So our rule for this when we have power to a power is we multiply. So this is the same as saying m to the 6 times 8, or m to the 48th power, right? So for this one, you might want to try and add these, but remember, we only add when we're multiplying our like bases. When we have power to a power, we need to multiply our power, all right? So we multiply 6 and 8, and it gives us 48. All right, and then the last problem for that first section that you guys were solving was x to the negative 1st power over top of y to the negative 2nd power and z to the negative 3rd power. All right, so when we're solving these, depending on the directions, but most of the time we do not want to have any negative powers. So we need to go ahead and we need to rewrite these. So all of these have a negative power here, and the way that we take rewrite it so that we have a positive power is we take each of these reciprocals. So since x is in our numerator, it then will need to be rewritten in our denominator. And you don't have to write the first power, but we're just going to for now since it was written there. This y, in order to make it positive, it needs to then move to the x moves to our denominator, y moves to our numerator, so it becomes y squared. And the z will also then move to our numerator, so it becomes z cubed. All right, so this is our final answer. So this one, when it's saying simplify, and that's just your directions, we don't want to have a negative power for that. So we get rid of our negative powers. There will be an example later on where we will have a negative power, and I'll explain the difference when we get to that problem. But when it directions, we'll just say simplify. When it's just simplify, we do not want any negative power, so we had to rewrite all of them. All right, so now the next ones that we're going to start doing is the second section. And the directions for these were just remove the brackets, all right? I'm going to leave the directions on top of these instead of what I was just doing. But it's remove the brackets. So we have 2x squared y, and all of this is being raised to the 3rd power. So remember, when we have multiple variables or coefficients that's being raised to the power, we are going to distribute this power to each of these. So we distribute to 2, we distribute to the x squared, and we distribute it to the y. So we can rewrite this then as 2 raised to the 3rd power times x squared to the 3rd power times y to the 3rd power. And we know our rule for power to a power is we multiply. So this is understood to be a 1, and so is this one here. So then we have 1 times 3, so it's 2 cubed. Then we have 2 times 3, so it's x to the 6. And 1 times 3, so it's y cubed. And since this is a number, a numerical value, we can actually keep going. So we would simplify this. And we know that 2 cubed is equal to 8. So this would then be 8x to the 6, y cubed. All right, and that would be your final answer. All right, let's move on to the next problem. All right, the next question for that section 2, it was 1 over 5n raised to the 3rd power. And the same thing as before, this power needs to be distributed to every single coefficient or every single variable. So the 1, the 5, and the n. So we can rewrite this then as 1 to the 3rd power over top of 5 to the 3rd power times n to the 3rd power. Now, all of these powers that we have here are understood to be 1. So all of these are just going to end up being written to the third power. So it becomes 1 cubed over 5 cubed times n cubed. And then we will just have to simplify this even more. And it becomes 1 cubed is 1, 5 cubed is 125, and it's n cubed. So that will be our final answer. All right, remember, I am going through these quickly. If you have any more questions, just make sure you message me. All right, so then the third question that we had for this one is we had x over 5y squared to the negative third power. So remember, and first thing we want to do is we want to get rid of this negative power. You could do this other ways. This isn't the only way that you can do this, but this is the way I'm going to show you here. If you know another way and you want to do it the other way, perfectly fine. But I'm going to first rewrite this so that I no longer have a negative power. And remember, when we do that, we need to take the reciprocal. So we need to go ahead and take the reciprocal for this one. So whatever was in our numerator, we need to write in our denominator and vice versa. So it becomes 5y squared over top of x. And by taking this reciprocal, that power now becomes positive. And now we take that power and we distribute it. We distribute it to every single variable or coefficient that we have with our fraction. So this then becomes, so I'll write this over here, it then becomes 5 to the third power times y squared to the third power over top of x to the third power. All of our powers that aren't written are understood to be 1. So our rule is we multiply. So then it becomes 5 cubed times y to the 6th power, because we multiply over top of x cubed. And then the last thing is we need to write the answer and simplify even more. So 5 cubed we know is equal to 125, because we can actually do that. So we need to simplify that, and it becomes 125 y to the 6 over x cubed. All right, that's it for this problem. And then one more in this section. We're moving on to the third one. All right, now the last problem that we have for this section, we were given 3a squared times b times c to the 4th power. And this is being multiplied by 5a b to the 6th and c to the negative 2nd. So this one, when you guys are doing class, seem to have a lot of trouble with. So whenever we're multiplying multiple variables and multiple coefficients, we need to make sure we multiply our likes with our likes. So the first thing that we're going to do here, since nothing's being raised like to a power out here, we just need to go ahead and multiply our likes with our likes. So we would do 3 times 5, and 3 times 5 is 15. Then we will move on to our next like variable or like coefficient. We have a squared and a. So now we know our rule when we multiply is we add our power, so it becomes a squared plus 1 or a to the 3rd power. Our next one, like variables that we have, is b and b to the 6. So once again, this will then become b to the 1 plus 6 or b to the 7th power. And then our last one is the c to the 4th and c to the negative 2nd. So from here, our rule is we add, so it becomes c to the 4 plus negative 2, and that is c squared. All right, that's the final answer. You guys were not multiplying the 3 and 5 in class today. That was one of the common mistakes, but whenever we have coefficients, they just get multiplied together. And then some of you guys were multiplying these, so you're doing 4 times negative 2, which would then be negative 8, and you were trying to simplify from there. Just remember, just because there's multiple things going on, we don't change any of our rules. When we multiply, we add our powers. All right, so that's why we had to do 2 plus 1, 1 plus 6, and 4 plus negative 2. All right, that's it for this section. There's 2 more sections in this video that we're going to cover. All right, so the next direction said write with a prime number base. So that means that our final answer needs to be in the form of a prime number. So I'm just going to write prime number, and then it needs to be raised to some power. So we need to have some exponent or some power that is being raised to. All right, so this is the way that all of our answers will need to be finalized. So this is one of the examples that we may have a negative number in our power, and that is fine because we don't want to have any fractions with this. We want to just have a prime number raised to a power. And remember, our prime numbers are 2, 3, 5, 7, 11, and so on. All right, so those are some of the numbers that we will have to rewrite this. So the first one we have is the 5th root of 16. So the first thing that we're going to do is we're going to rewrite this with a rational exponent. So here we have our 16. That's going to be the base of our base of our number raised to a power, the base of our rational index in this index. So from here, We know that this power, when it's not written, is understood to be 1. So it's 16 to the 1/5 power. Remember, it's power over index, power over index. So now we need to rewrite this, though, as a prime number raised to a power, and 16 is not prime. So we can look at these and say, which one of these numbers can we rewrite raised to some power that's equal to 16, and that is 2. And we know that 2 to the 4th power is equal to 16. So I can replace 16 with 2 to the 4th power. And my rule now that we have power to a power, because now it's 2 to the 4th raised to the 1/5 power, is we multiply. So 4 times 1 over 5. This is understood to be over 1. We multiply our numerator with our numerator and our denominator with our denominator, so it's 4 over 5. So this final answer is 2 to the 4th fifth power. This is being rewritten as a prime number raised to a power. So that's what we mean with the prime number base. All right, so all of our answers for this, we can't have any fractions as far as 1 over something. We just need to have a singular prime number that is raised to a power. All right, the next one now, it is 1 over the cubed root of 9. So for this one, we're same thing. We're going to first rewrite this. So it's going to then become 1 over 9. Our power for 9 is 1. Our index is 3, so power over index. So it becomes 1 over 9 to the 1/3 power. Now we want to rewrite this 9 as one of our prime numbers raised to a power. So 3 we can rewrite, and it can then be 1 over 3 squared to the 1/3 power. And now our rule with power to a power is we multiply. So 2 times 1/3 is equal to 2/3. So now this is then going to be equal to 1 over 3 to the 2/3 power. Now remember, we only want a prime number base. We don't want anything else. So this is not written as a prime number base because we have a fraction, we have a 1 in there. It's not just a prime number. So we need to rewrite this. So we have to rewrite this with only our prime number base. So we need to figure out a way that we can rewrite this so that 3 is in our numerator and there's no 1. And remember, if we have, say, x to the -2nd power, we can take its reciprocal and it becomes positive. We could do that in reverse. It's positive here, and if I want to rewrite it so I just only have that base, I can rewrite it in my numerator, but that means I have to then rewrite it as a negative number, a negative power, because we're then rewriting it, we're taking its reciprocal, we're going from the denominator and moving it up to the numerator. All right, so this would then be our final answer. So this is one example where we will need to leave it as a negative power because the directions are telling us that we want it in just a prime number base. All right, then the last one for this section, it was 8 squared. So we need to rewrite this as a prime number. So which one of these numbers can we rewrite 8 as one of these prime numbers raised to a power? And that is 2. And we know 2 cubed is 8. So we can then rewrite this as 2 cubed because that is equal to 8. And then it's still being squared, so 2 cubed being squared, and that is going to give us our final answer as 2 to the 6th power. Right? You don't actually have to simplify and figure out what the numerical value is because it says right with the prime number base. It doesn't say simplify. If it said simplify, then we would actually have to go ahead and say that this is equal to 64. All right? But it just says rewrite as a prime number base, and that is your final answer. All right? If you have any questions, let me know. There's one more section in this video that we're going to go over. All right, so the directions for this say simplify, giving answers in simplest rational form. So this is an example then where we cannot have negative powers because we're not asked to rewrite as a prime number raised to a power. This is saying simplify, and whenever you're asked to simplify, you cannot leave a negative power. So the very first question that we had was 7 to the -1st power. So we need to get rid of this negative power. So in order to do that, then we need to take its reciprocal, and it's 1 over 7. And that's the final answer. All right, pretty simple. If you have any questions, though, let me know. All right, then the second question that we had here, it was 4 to the 3rd power being raised to the -1st power. So this is pretty similar to what we had in the second section that we did because we had a -3 power for that one. But now there's nothing that we even need to really distribute this to. All we have to do is take this reciprocal, and that will then change this to a positive power. So this is equal to 3 over 4. We don't have to rewrite it raised to the 1st power because anything raised to the 1st power is itself. So all we needed to do is rewrite this so that this -1 was no longer a negative, and we just take its reciprocal. All right, that's it for this one. One more question, and we're done with this video. All right, now the last question was 11 to the 0 power minus 11 to the -1st. So here we need to go through it step by step. Anything raised to the 0 power we know is 1. right? That's one of the rules that we discussed. It's one of the rules that we learned. So anything raised to the 0 power is 1. So this 11 to the 0 power is equal to 1. Now here we have 11 to the negative first power. So we need to get rid of this so it no longer has a negative power. And that means we need to take its reciprocal. And it becomes 1 over 11. So now we have 1 minus 1 over 11. In order to add or subtract fractions, we need to then have common denominators. So we multiply this by 11 over 11 so that we have the same denominator. And 11 over 11 is equal to 1, so we're not changing this value or anything like that. So now we're going to rewrite this over here. So 11 over 11 times 1 is 11 over 11 minus 1 over 11. And that final answer, 11 minus 1 is 10. So it is 10 over 11. All right, that is it for this video. There's one more video for the last 3 sections that we were doing for a review. Remember, I went through these kind of quickly, and it's because we've already did this. You already did this in class. It's just a way for you then to hear it from somebody else if you're still unsure when you're working with your group.